Hello, hi, welcome back again to my channel. On this video we're gonna discuss the following puzzle, which is the newest puzzle from Catriona Shearer. So it was published probably yesterday. Okay, so we have a rectangle, okay, the outer rectangle here, this one, the rectangle, and then the diagonal divided the rectangle into two regions. Each contains a trap square. Okay, and then the other information that we know is that the line segment of the same color is of the same length. So these three red lines are of the same length. So the question is, what is the proportion of the total area of the squares compared to the area of the rectangle? So if you haven't seen this problem before, it is advisable to try the puzzle yourself first. Okay, so pause the video for a moment and give it a try. Please pause the video now. Okay, now let's discuss the problem. Okay, since this is about proportion, then we can declare one of the length to be equal to any number. Let's say 1. Why is that so? So let's declare that this is equal to 1. Okay, why we can say that this is equal to 1? Suppose that it is not 1, let's say like what, 6 centimeter, for example, the actual length. Then we can declare a new unit. Let's say 1 new unit length, NUL, is equal to 6 centimeter. So we can express everything in terms of this new unit length. So it doesn't matter whether it is equal to what is the actual length of that red line. We can always declare it to be equal to 1. Right? Okay. So, but now once we have declared one of the line segment is equal to 1, then the other one is dependent on this new length segment. So then we cannot declare the length of the square to be any number we want. So let's say we have that the side length of the square is equal to x. Okay, and this one will become 1 plus x plus 1. Okay, now notice that this angle and that angle is complementary because they add up to 90 degrees, right? So therefore this angle is also the same as that angle, and this guy is also complementary to that angle. Okay, so what else? This guy is, oh, this should be just a dot. Okay, this is a dot. The dot is complementary with the arc. Okay, and this is complementary to the arc. It's a dot. Okay, so then we have several similar triangles. So for example, that what we want to emphasize is that this triangle, this triangle and that triangle are similar, right? Because all the angles are equal, right? So, well, you can argue by trigonometry, but I'm trying to avoid that in case that some students have not yet seen trigonometry, so they can argue by using similarity. So since these two triangles are similar, then the proportion of this, the leg or the sides of the triangle which is not a hypotenuse is being preserved. So it means that this over that, so we have, okay, let me repeat again, this triangle and that triangle is similar. So the proportion of the hypotenuse to the hypotenuse and the vertical to the vertical and the horizontal to the horizontal are equal. Okay, so then we have, for example, if we compare the base, right? So if we look at the base of this triangle, let's think of this as the base, and this is also the base. This is, we can think of this as the base of this triangle, and this guy is also the base of that triangle. So then we have the proportion of the base of the bigger compared to the smaller is x over 1. This is equal to what? Equal to the straight of the bigger triangle, which is x plus 2, over the straight one of the smaller triangle. Okay, so that's what we have. So x need to satisfy this equality. If we simplify, we have x squared is equal to x plus 2, x squared minus 2 is 0. We can factor this as x minus 2, x plus 1 equals 0. Okay, so x is equal to 2 or x equal to negative 1. Since x represents a length, then x must be equal to 2, right? So x is 2. Okay. Okay, now we need to compute the area of the big rectangle, right? So notice that this triangle made up of the sides of the rectangle and the diagonal is also similar to the previous two triangles, right? Why? Because all the angles are equal, right? The dot, the arc, and the 90-degree one. So it means, again, the proportion are being preserved, right? So if we call this to be, so let's see. So for example, the proportion of the base to the height, right? The base to the height, which is this, the base to the height. Remember that x is equal to 2, right? So this is equal to. So then we know that the proportion of the base compared to the height is 1 to 2. Or in trigonometric language, the tangent is equal to 1/2. Therefore, the proportion of this base compared to that height is also 1 to 2. So if we call the length of this side to be s, then the length of that side is equal to 2s. Right? Okay? And as this side and that side and together with the hypotenuse satisfy the Pythagorean theorem. So therefore, s squared plus 2s squared is equal to 2x plus 3, but x is equal to 2. So 2x plus 3 is 7. So therefore, 5s squared is equal to 7. 7 squared. I'm sorry, 2x plus 3 squared, which is 49. Okay. Now the area of rectangle is equal to s times 2s, twice of s. So it is 2s squared. So how to get 2s squared from 5s squared? We multiply with 2/5. So then this is 2/5 of 49. Let me leave it in that way. We don't start simplify the expression yet. And then how about the area of the square? Area of square squares is twice of x squared, because we have two squares, each of area 2 times 2. So 2 times 2 squared, which is 8. So the proportion that we are looking for, which is square compared to the rectangle, is equal to 8 over 2/5 of 49. And if we simplify, we get how much? 40 divided by 2 is 20 over 49. Okay, and we are done. Okay, so thank you for watching. See you again on the next video. Bye bye.